Hey guys, I'm Mrs. Delavecchia, and before we start, I want to remind you to take notes using the guided notes that are in your unit packet. Those notes will be a part of your grade. If you have any questions, write them down and we'll go over them in class. So let's get started. In this lesson, we will review how to find the slope of an equation that is in slope-intercept form, find its y-intercept, and then be able to graph it after that. So first, looking at an equation in slope-intercept form, it's always going to have the format of y equals mx plus b, or in other words, y equals a number times the x plus some constant. And when you're in that format, you can easily look at these equations and find out what their slope is. So in y equals mx plus b, the value that is the coefficient of the x, in other words, this m right here, is always going to be the slope. Okay? I kind of think of it like a mountain. M is for mountain. And what do mountains have? You go up, like if you go skiing, you go up the mountain, down the ski slope, right? Up and down are the slopes. So M, think of it as M for mountain, M is the slope. So very easily in this equation, we would have the slope is 3. So we could say slope equals 3. Now, when I go to graph this equation in a minute, when I think about the slope or graphing using the slope, I'm going to end up counting that and think of slope is also rise over run. All right. And so how much does this rise? Well, 3 could be also represented as 3 over 1, right? That's equivalent to 3. So when I'm thinking of slope, and it's just a whole number, I want to think about that as 3 over 1. So this means I would count up 3 and I run in the positive direction 1. Okay, so this one, now I only have a negative in front of this x, so the slope is the coefficient of x. Well, what is that then? What is the slope? It would have to be a negative. If there's not a number in front of a variable, we know its coefficient is 1 because there is one of them. There's one x there. So this would be negative 1, and then I'm going to put it over 1 so that I have the rise and the run represented. So when I go to graph this, I'm not going to go up 3. It's a negative number. I'm going to go down 3. I'm going to fall 1, sorry, 1. And then I'm going to go over 1. Okay, let's look at this one's a little tricky. I've got x divided by 2, and then I don't have anything else with it. So another way to think of this, if you see something like this, would be 1/2 times x, right? Because dividing by 2 is the same as multiplying by 1/2, so that can be rewritten this way. And then I don't have anything else with it, so that would be plus 0. And we're only looking at the slope right now, so really I'm only concerned with this number right here. So now I can say my slope is 1 over 2. That means when I go to graph this, I'm going to rise up 1, go up 1, and then I'm going to count over 2. All right, so now let's look at what the y-intercept in y equals mx plus b. Okay, the b value is your y-intercept. Okay, sometimes people remember, well, when I go to graph, I begin with the y. B is for begin. I begin with my y-intercept. However, let's look here. So again, our slope is 3 and our y-intercept is negative 2. So that means this is going to hit the y-axis, xy, at the value negative 2. Okay, sorry. All right, this one, my intercept is positive 5, so it's going to hit the y-intercept at positive 5. And again, here we said we could rewrite this as plus 0, which means this is going to hit the y-intercept at 0. All right, let's take a look at the next thing, which would be graphing these equations. So the first example, again, same equation. We said that the slope of this was 3, which I could write that as 3 over 1. My y-intercept is -2. So how do I graph this? I'm going to start and put a point at -2 on my graph, right there. Then I'm going to use the slope to count my next point. So I'm going to go up 3, 1, 2, 3, and over 1. And I'm going to put a point right there. And just connect those, and this is graphed. That's all you do. Easy peasy. You could count again, 1, 2, 3 over 1, and then keep connecting that. Of course, this is hand drawn, so it's going to be a little off, but you can keep counting if you need more points. But as long as you have 2 points, you can connect them, and that's your line. All right, let's look at this one. X over 2. So again, the slope was 1/2, and the y-intercept was 0. So I'm going to start and put a point at 0. Then I'm going to count up 1 over 2, put a point there, and now I'm connected. And that would be that equation graphed. One more. My slope is -1. Put that over 1. My y-intercept would be 5. So I'm going to start with a point at 5. Then I'm going to count down 1 and over 1. I might do that a few times. When they're very close together like that, you may want to down 1, over 1, down 1, over 1. And you'll get a very good idea of where those should connect. Like that. Let's talk real quick about what happens when you have horizontal and vertical lines. So if I had the equation y equals 6, right? Well, if y equals 6, y is just saying y is 6. So whenever there's a y value on that line, it will be 6. So what it doesn't say is we don't know what the x values are. So the x could be anything, but y is always going to be 6. So this becomes a horizontal line going through y equals 6. So the slope of that would be 0. And it would be a horizontal line. X equals -3, again, is the same idea, but all the values for x are -3, and y can be anything. So if I graph a line, no matter what the coordinates are, the x value is -3, y can be anything. So this is going to be a vertical line, vertical, and this is considered to have a slope that is undefined. And why is that? Because if you actually went to calculate slope, slope is also the change in y over the change in x, which is the same as the difference of the y's, over the difference in the x's. So if you pick any 2 points on here, let's pick this point and this point, okay? This is the point -3, 4, and this one is the point -3, 2. All right, so let's calculate the slope. The change in y would be 4 minus 2, and the change in x would be -3 minus a -3. 4 minus 2 is 2. -3 minus 3 is 0. And we know that you cannot divide by 0. So anytime you have a vertical line and you put in the numbers for the slope, it's going to come out with something that requires you to divide by 0. And that's why we say that a vertical slope is undefined. Let's go ahead and calculate this one real quick. So let's just take 2 points here and here. This is the point 1, 6. This is the point 4, 6. Okay. Change in y is 6 minus 6 over change in x, which is 4 minus 1. 6 minus 6 is 0. 4 minus 1 is 3. 0 divided by 3, 0 divided by anything is still going to always just be 0. So that's why a horizontal slope is a slope of 0. A vertical slope is undefined because you would always be dividing by 0. All right, so we talked about y equals mx plus b, the slope-intercept form. The m value is the slope, the b value is the y-intercept, and then to graph it, you plot the y-intercept, and then you count the slope. And that's it. Have a great day.